Hey everyone, it's Jad here. Today we are tackling the LeetCode problem, Subtree of Another Tree. I'll walk you through how I'd solve this in a coding interview, from understanding the problem and devising a plan to coding, testing for errors, and evaluating time and space complexity. I'll be solving in Python and I'll think out loud and ask clarifying questions just like in a real interview scenario. Let's get started. First of all, I'll start by looking into the problem statement. So given the roots of two binary trees, root and subroot, return true if there is a subtree of root with the same structure and node values of subroot, and false otherwise. And a subtree of a binary tree is a tree that consists of a node, entry, and all of this node's descendants. The tree could also be considered as a subtree of itself. So, I'm given two trees here. They are optional tree node, where a tree node, it has a value, a left that is also a tree node, right, that's also tree node, or none. So it's optional because it can be none or tree node. And we want to return a Boolean if subroot is a subtree of root. What does this mean? So if we look into the example one here, we are first given this root. So 3, 4, 5, 1, 2. And if we look into 4, we can see that 1 and 2 are there. Okay. So I have a few questions here. So first of all, can the root be none or subroot be none? And if it is the case, do we consider none a subroot of all the trees? My answer would be yes. Let me confirm it with the constraints. So, okay. First of all, we are sure that the number of nodes in the root tree is in the range 1 to 2000, and the number of nodes in the subtree is in the range 1 to 1000. So we know that subroot and root are not equal to none. That's one thing. And that their values are between, they are either positive or negative. That's what we need to keep in mind. And so how would I proceed here? So actually what I would do here, so one thing to note here is it's a binary tree. That's why we have left and right. And that's one thing. And so one thing to note is we will be so the way to go through root is to do a recursion. So we will look into 3, then we'll go to left, then to right. Okay, this is the way to proceed. And so one thing to note is, so we are checking if subroot is a subtree of this one, which means that at some point, one tree should equal to this subroot, right? So maybe I can define an auxiliary function method that would take two roots, root 1 and root 2, def are same trees that take root 1, that is an optional tree node, and a subroot, a root 2, that's also an optional. So I've started coding here, but let me give you what my plan is. So in short, the first thing is I'm defining a method are same or same, yeah, trees that take root 1 and root 2 and return boolean true if true or false, and we will be iterating over. So we do not need this root 2 actually. Is subroot. Okay, I can call it, so this is a good thing to actually first devise a plan before trying to code here. So I will have a method, a helper method that gives me the following: is subroot, and that takes a root. I can say given R, that is actually, and we compare it with. So this method compares the given node. I can call this node, right? Or tree. With subroot and returns true if yes, else false, right? And what we do is we go through all the nodes of root and run is sub root, and as soon as we find one if go through all the nodes of root and run the helper method, and stop as soon as true. And in here, we have to stop as soon as false. Right. Now that we do have this, let me define the helper method is sub root, and we get the R. Maybe it's a better. Maybe node is a better. Yeah. Because it's not the. There we go. Optional tree node. And if and the thing is, we have to also keep track of the subroot. So I could maybe call this R and SR of R for the root and SR for subroot. I mean, maybe not, but let's make it clear. Node subroot node. So we can have subroot node, root node, maybe subnode, yeah. There we go. Let's call this node and the other one sub node. And now that I have this is also an optional. If both of them are none, we return. If not node and not subnode, we would immediately return true. If one is so or not. We are returning false because if both of them are none, it's enough. If one is none and the other is not, we return false. Now that we have cleared these conditions, Now we can move on with we can return, first of all, if node dot value subnode dot value, or so one thing to note here is, yeah, if both of them do, if one of them has left and the other one has left, yeah, okay. Let me write this down a bit differently. If not, oh no, I think it was a good idea to leave it that way. If node dot left, if not sub return false. That's pretty easy. If node not left and not node, I mean, node okay. Maybe I should just, yeah, we don't care about this one because we confirmed, because can I access node.left and node.right? Yes, I can, because they are at least equal to none. So I can do this, right? Or is subroot node.left subnode.right and is subroot node.right, sorry. Yeah. So what are we doing here? I'm having this is subroot that takes a node and a subnode. So initially I will be putting here root and subroot to see if root and subroot are equal. And what do I check? If the node is not, is empty, is none, I can maybe call it if node is none and subnode is none, I would return true. if node is none or subnode is none, that means that one is none and the other is not, we should return false. There's a difference, right? And we return, now we know that both of them are not none, so we can compare node val and subnode val, and we compare node left and subnode left and node right and subnode right. So if we apply it here, so let's say here I've given this node and this node. So this is not empty. This is not a none. So we end up here, 4 is equal to 4, and we get this node, and 1 is equal to 1, 2 is equal to 2, and then this left is none, and this left is none. So it is none, and the other one is none, so it's okay. It's true, it returns true. And so, yeah, we end up with true for this one. Now that I do have this method, I can implement the isSubtree method, that is while, so I would be returning false if I do not find anything. I mean, no. So what am I doing here? So I'm using a current that's going to be root, and maybe not. I can use an array, that is the queue, and while queue, that means that queue is not empty, I'm actually putting root in there. I know that if is so current is queue, we know that root is not none, but we don't care about that actually. While queue, we get the current, that is queue pop. Then we get left and right, so we are adding them. If current has left, if current left is not none, I can just put if current left. Q is getting left. If current right, Q is getting right. And what I'm doing here is if is subroot. For node, I'm giving current, and for subnode, I'm giving subroot every single time. And if this is the case, return true immediately. And if not, we continue with appending and popping things. So let's try to apply this second example here. So what happens here is that I do have this method, and I have this queue. Okay, first of all, root is this one, so I'm adding this one here, while queue, so there's something in there, which is the root, so I'm popping it out into current. And I'm checking if this is, if subroot is equal to this one, I can rename this r equal, so r equal, and this is the method that I'm calling here. So r equal, and I'm giving subroot here. 3 is different from 4, so it's not, we are immediately returning false. So we are adding 4 and 5. 4 is there, so I'm popping it out, r equal, and 4 is equal to 4, so that's okay, and r equal left, so 1 is equal to 1, that's perfect. 2 is equal to 2, so this one is perfect too, but here 2 gives me 0, so while this one is none, right, I'm giving none to the left, while 0 to the left here. And we know that if subnode is none, so both of them are not none, but one of them is none, so we return false. And because we return false and this is an AND, we will be returning false for this one, so they're not equal. So we continue adding the other ones, and we end up with returning false. Let's now execute this. There's a problem here, and left is not, my bad. There we go. Let's now try to execute this. So it worked. Now let's try to submit the solution. It worked. So in terms of time and space complexity, for time and space complexity, we are iterating over, not iterating, sorry, we are going over all the nodes in root. And for each of them, we are going over the nodes of subroot. So it's O of n times m, where number of nodes in root and m the number in subroot. And the space complexity is the so we are doing a recursion here. But we do not store anything else. So it's O of n, O of 1, sorry. That's it.